Okay, so we're asked to find the results for this equation between 0 and 360. What we want to do is get this into a quadratic format, right? But the quadratic has to be in terms of one trig function. Now notice here we've got sines and causes. That's no good. We need to get it for just one of them. The one we can't change is sin x. We can't change sin x, so I'm going to change this here to get this in terms of sin x. And remember the result then. Sin squared x plus cos squared x is equal to 1, so that's true always. So we can use that result to rewrite cos squared x to be 1 minus sin squared x. So if I sub that in then for cos squared x, I get, instead of cos squared x, I can put 1 minus sin squared x. And you'll notice then my equation has everything in terms of sine. So I get 10 sin squared x minus 3 sin x equals 4 minus 4 sin squared x plus 1 there at the end. Get everything to one side, so I'll get 14 sin squared x minus 3 sin x, okay, minus 5 equals 0 when I do that. And you can see then I've got a quadratic, okay. So with a quadratic, we often look to solve by doing two brackets. We can't simplify it down first, okay, there's no common factor here, so we go straight for the method we usually use. So the method we often use is two brackets, put 14 sin x in both. Okay, multiply add thing over here then. Now, of course we want them to multiply. Remember we're going to multiply that first number by the end number. So we want them to multiply to give minus 70, add up to give minus 3. Okay, pair of numbers, so you just got to think of a pair of numbers that multiply to give 70. 10 and 7 are the obvious one to me. And when you think about it then, 10 and 7, you can get it to add up to give minus 3. If you make it minus 10 plus 7, yeah? Okay, that's the approach we can use there. So minus 10 plus 7 is what we've got there. So then, remember, with this method, you sort of got to divide them by what we timed at the start. So we've got to divide by 14. You can see in the first bracket there's a factor of 2. And the second bracket is a factor of 7. And then you divide by 14, and then those factors will cancel out, won't they? Because 2 and 7 there times to give 14, and 14 divided by 14 cancels them. So you've got 7 sin x minus 5 equals 0, or 2 sin x plus 1 equals 0. So you need to say then sin x equals 5 over 7, or sin x is equal to minus 1/2. When you take the 1 over, it becomes minus 1 divided by 2. So then we've got to use our calculator, yeah? So we need to work out one of these results. Sine to the minus 1 or 5/7. So if we work that out on our calculator, we get, let's see what that comes out to be, 45.6 degrees. Okay? One result there. To get the result from this here, to get the x, we do the same. Inverse here of minus 1/2, and that comes out to be minus 30. Now these are two solutions, okay, but remember we want all the solutions between 0 and 360, okay, between 0 degrees, 360 degrees. Now that one is actually outside of that range, but we can still use it, can't we? We can use it to find the other solutions. 45.6 is in that range, which is great. So we're going to draw a sine graph. Remember, when you draw your sine graph, okay, what's important is you get a consistent scale. Okay, so I've just drawn like a y-axis there of 8 centimeters, and I've cut it in half. Now, with the horizontal axis, remember we need to go up in 90s. So perhaps what would be good is to every 3 centimeters would represent 90. Okay, so that'll do that. And of course we need to go back to minus 90 as well. Okay, so we could put in 0, 90, 180, 270, 360. That would be my x, and minus 90 there, of course. Remember then sine, the most it can be and the least it can be 1 and minus 1. Okay, cannot go above 1, and it cannot go less than underneath minus 1. Comes to drawing a sine graph, you know what it looks like. Okay, so sine wave, but in the exam you can always check where the curve goes through. So in this case here, when x is 0, you can type in your calculator, can't you? Sine 0 is 0. When it's 90 degrees, sine 90 is 1. 180 degrees, sine 180 is 0. 270, sine 270 is minus 1. 360, sine 360 is 0 there, and the same then, sine minus 90 is minus 1. So it looks like it's zigzagging, but we need to obviously draw a curve there, okay, to get the sine wave as it should sort of look like, okay. The fact that we've drawn a scale, accurate scale, really does help us get a realistic sort of sine looking graph there, okay. So what I'll do then is I'll work out what the other solutions are. So 5/7, now when sine x is equal to 5/7, if you think about it, 5/7 is 0.7, so it's going to be about there, isn't it? Yeah, 5/7, 0.7 is roughly there, isn't it? Okay, so if I draw a line across, you could see then where it hits the graph. So it hits the graph at 2 points. So the first point is my solution there, yeah, 45.6. The other point will be the other solution. And because it's symmetrical, you've gone across 45.6 there, you're going back 45.6 there. So the first solution, I can write down here, second solution is, well, you're going back 45.6 from 180, so it'll be that there. So we get 45.6, x will be, and then when you work that out, it'll be 134.4. Now the other solution is when it's equal to minus 30, but of course that's minus a half. Sine x is equal to minus a half. Minus a half is about down here. So you've got your solution now, minus 30. Now that's outside of our range, we want to be in here, don't we? But you could see then our two solutions, here and here. So to get that one, well, you've got to go across 30, yeah, due to symmetry. So it'll be 180 plus 30, and then backwards 30, so 360 minus 30. So the other two solutions will be 210 and 330.